Okay, we are back. Hi. Let's get some stuff on the website, eh? We are. Terraform does not run. Second. Failed to load resource. Okay. Ah, that's fine. That took surprisingly long. It's only a meg though. Okay, so this is failing to load shaders, obviously. I forgot to write those. Shit. I totally forgot about that, didn't I? That's kind of bad. Okay, here's what we're gonna do. We're gonna move terraform to top level N. Fix tower climb. Close seg fault. Yeah, PR? I have to do the shader for this. I forgot that I didn't do the web version of the shader. So I will do that. Put it there. One giga PR, that's fine as long as you don't break other stuff in PufferLib in the process. So if it's not touching other files, that's fine. Like other than those M's. You know? And I can do that right now, man. Like, I want to get this stuff done. I'm sick of dealing with this update. Like, this thing just needs to be done. Policy.c. So, Spencer, one thing that you should try before you go ham on that is, like, if you just throw a linear LSTM at it, doesn't do anything. Possibly with a one-hot encode if you have one-hot data. Because, like, I did that for some other M's, like, I did that for Snake and stuff, and, like, as long as you don't feed in one-hot data without one-hot encoding it, Flat actually will do very well very often. And then you can, like, trivially just copy the policy in. Not saying to use that for everything, but just for, like, a quick web demo. I don't want people spending forever on like individual C policies when like realistically we're just gonna have to come up with a easier way to make our C policies, right? I had an idea for that even. Yar. Your Discord. I don't know why the Discord banner keeps breaking as well. Solid work. Files changed 1. Oh, 16. Okay, GPU drive, Terra, CPU binding, that's fine. Let's see. H, I. Terraform bind, Terraform C. Spacing change? What do you mean a spacing change? Oh, let me look. Added torch is fine. Okay, I did this to offset it, so that the target would like render a little above so it wouldn't clip, but that's fine. Wait, did you change parse? Oh, okay. I thought I'd made it transparent, but maybe not. Okay. Was there a PufferLib spacing thing? The heck? Yeah, that's just weird. What is this? Ever. That's fine. So let's see if this gets onto website. how big is it? How big is giant, right? Like, how big is the obs? If it's like many thousands, that's not going to be good. Yeah, so GPU drive, you'd have to like massively reduce road points. 300 to 400 is fine. Try it with Terra first. Just literally, it's the default policy with an LSTM, and just see what it does. Shouldn't take long. Is GPU drive not supposed to segfault? Maps? Ah, god damn it. It should not segfault when you do that, though. It's like, it should at least give you some sort of error. Segfault is like the worst possible thing. Backstop in.py. Found 0 JSON files. What am I supposed to do with this thing again? Damn it, yeah. We need to at least have one map, okay? Like, for... We need to at least have, like, one cool map in here by default. Just literally one. Like, one cool map by default. And then it should warn you when you try to train, right? Or whatever. That, like, yeah, hey, we need more maps. Or not even warn, it should just crash. But, like, it should actually say, hey, download these maps from here. The difference in number of people who will use this thing, if it like just works versus if it almost works, is going to be very large, man. It's like the same with all these ENVs. I can tell you that from experience on Neural MMO, like 1 and 2. I had stuff that was way easier to use in multi-agent RL than anybody else, but it was still hard. It was just easier than everyone else's, and it's still like people wouldn't put in the effort. Like they instead of using your thing that's like easier, they'll go do some other dumb thing that's like easiest. You know? Well, I could do research on neural MMO and that would be really cool, but I couldn't figure it out, so I decided to do my whole PhD on Atari. Like literally that. Also, Eugene's on vacation till the 24th, so yeah, this thing's gonna be released before then. Yeah, the thing is, it's not really that bad for us because we don't do strict versioning on our environments. Like there are some RL libraries where they're really strict about like, oh, it has to be, versioned so that like results in published papers will be directly comparable or whatever. I kind of just assume nobody's publishing useful papers, and like, it's better to just have the latest thing be the best thing always. Hunting for a cool map, good. Yeah, there's a lot of syntax bullshit. We'll have to just, like, we'll see if it works out of the box. It's easy conversion shit, I just don't write enough of these. Literally just like API versioning. That looks good, varying an attribute. That's roughly what I remember it looking like. Oops. Really annoying how it's different versions. It's one of the main complaints I have with PufferLib. Like, I wish they would just support some version that works on both. I think you should be able to use like 3.0 or something. You shouldn't have to use 1.0. And then that would be like good enough. Pose. Is this what it's supposed to look like, Spencer? Like, the out of the box doesn't look anywhere near as cool, right? Because it's like, it's basically already done. Got like a few chunks ripped out of it. I don't know if this is this curriculum stuff or what. Comment out the reset section. Well, I don't want to screw up the actual game. Because I don't want to, like, I can change the scene off the .h, yeah? Curriculum stuff, don't worry, it's experimental. Cool. Complete, so it's probably this thing. Do I need this? Do I go to here? Or do maybe to here? To this, right? Yay. Ooh, what is this, man? Like, it's just a shadow of where you need to complete now. Oh, is this my shader? But like, just, it's really low or whatever? Okay, that's fine. Little map. Where are those low poly dozers I sent you? I might just buy those to load one of them in. I think it'd look better. See if these have, like, reasonable... Of course, it's frickin' Unity. Very low poly. These look really good. Trying to think. FPX. You don't need to get a Perlin to Perlin policy for Elite Spencer. We always like too much feature creep. Just we use this. If we could get like a simple thing that we can at least load onto the web. Do it for the thumbnail. Do what? Scroll to grid. Yeah, I think if we like show it like partially being completed, it'll be cool. Oh, I have to. The card's expired. I have to add. I think it's gonna be on me for then after that to like get something reasonable. Any like aesthetic changes now would be the time because I'm basically after this, I'm just gonna get these onto the website and then I'm gonna try to get the trailer person hired today. I'm basically just gonna go around on Upwork to find somebody who doesn't seem like a total shitter. Upwork is kind of a mixed bag. It's like there's some ridiculously talented people on there working for like nothing, where it's like you end up just tipping them the whole price of the order because it's like, what are you doing? And then there are people that are just like have absolutely no value. Where it's like, dude, you just typed this thing into GPT. Is all you did. Write-ups are good. I gotta start on that as well. Well, I actually have a few of them ready to go, to be fair. Unity. Yeah, that's what I'm doing. I have to. It's kind of awkward. Like, they don't let you download your stuff directly. They make you download them with Unity, which I think is just really gross. Yeah, the fact that they don't have a download button is just disgusting. It's like they don't want people using their shit outside of Unity or whatever, I guess, which is dumb. Hey, Diego, so I'm just trying to get these assets that I got. Where the heck is this? Here we go. See, this is so ridiculous that they don't let you download it without getting Unity. But now... Yeah, so now I should be able to... Is there a way to run auto-tune on 3.0? There should be. You might have to just call the function, though, directly from Vector. Because I haven't messed with that in a while, man. I should actually fix that up. I just haven't messed with it in a while because, like, we don't need to auto-tune any of our new ends because they're so fast, you know? But you totally can do it if you just run from Vector. Most of the time, though, like, picking some multiple of ends and then double or triple buffering is going to get you most of the way there. Okay, here we go. Go away, Unity. Nobody likes you. Go away. Doesn't even... There it goes. Now we go to the program that doesn't try to do scummy things. Yay. Eh? ASCII FBX files are not supported. You'd be kidding me. This is a cool digger. Dump truck. Where's my dozer? Wait, what? They said there's a dozer. What's this? This is a really good online viewer. Like, they actually did a pretty good job with that. Wait, what? These are not the, Well, this is not it, yeah? Not it either. The hell is our model? One. Oh, there it is. I'm just dumb. Okay. Obj. Can you look at env? Yeah, can do. Give me 1 second to finish this. Driving me crazy. Texture not mapping annoying. Alright though. I will I'll look at env. You can go ahead, link code in Discord. Do clip for Terra. See. Yeah, that's good. I do kind of want to load this dozer in though, so that's going to be the main thing. I'll need the policy. Code. See your code. This is polytime. Yep, I remember this. What did you want me to look at specifically, Doctor? Yeah, performance is like plenty good, man, to have on the site. We're gonna stop spending like we're gonna stop doing this thing where we spend 2 weeks building an env and then like 3 months agonizing over the details of the env, and instead we're gonna do 2 weeks building the env, try to find client, fund more science. That's gonna be the plan. I can't get 1 mil. Okay. I will take a quick look. Flying around the map. It's funny. Well, this thing doesn't build as is. So yeah, so this is supposed to be of 0. This is a perf test, I imagine. And it's slow. Wait, max agents equals 500. Is it 1 agent or is it or is it like 500 agents? What is it? Wait, what? You have 1 agent or 500? Not Marl. Why is it? Why are there multiple agents in here? RL agent is 1. But do you have 500 total? Like, okay. Wait. How the hell does this make any sense? Okay, this thing is just like not structured in a reasonable way here. Because like, you're indexing based on tape size and items, but like actions is supposed to be a fixed space per agent. And then like in the .c, the only thing you're doing is setting the action index 0 to 0. Something is like confused here. Tape size and max items are fixed. Okay, but you're still setting action index 0. I think tape size plus max items. Used to have a script in here to download weights to bin. Puffer export, Spencer. Puffer export, Terraform, load model path, your model. It's wrapped into the CLI. .500 items. I don't know what this item is because it's a Turing machine. What is an item in the context of a Turing machine? I don't understand why there are 4 agents, why it's a multi-agent Turing machine if they're not all AI controlled. Yeah, sure, I can chat. You on the right track here?
Hey, am I audible?
Yeah, hey.
Yeah. So actually, it's only one agent. Basically, the problem is solving EFX allocation. So there are multiple agents which need to be allocated items, and they have utilities. Like each agent has a utility for an item. So the agent is not like like real multi-agent RL. It's just the uh, like the agent is only one. It's solving basically which agent gets which item, so that so that the allocation is NV free.
So then is the RL problem, is it like on the allocation or is it like an action of an agent?
like it's on the allocation. So the RL problem actually solves for the allocation, not
Okay, so then the
completely.
agent is not the thing. The thing that it's being assigned to is not the agent. The agent is the allocator.
Uh, no, actually we allocate items to agents.
Okay, then what's the action space? By what mechanism do you interact with this thing?
So in one for like when we take an action, we set the memory, the Turing tape, and the result and the halt flag.
But how I don't like there are two different problems here, right? Like how is it an allocation problem that's also a Turing machine problem? Like I'm
Uh,
confused.
okay, so basically what I'm trying to learn an algorithm that allocates. So
You're trying to
so
learn an
the
algorithm
algorithm
that allocates.
that has, yeah.
Something's got to happen with the action space here because the action space is like nuts. Um, like here, let's do it this way. So the action space is the tape size plus the max items plus one. What is the action supposed to do? Like, how's it supposed to be
Yeah.
interpreted?
So the action basically what it does is at this moment um, it assigns the memory. So whatever uh, like if the action space is tape size plus max items plus one, the tape size part of it just copies whatever it has outputted to the memory tape. It just updates the tape. I'm planning to change that, but yeah, for now it updates the tape, the
Wait,
the memory of the this,
the
and
whole
then
tape at
the
once.
yeah. So
And the tape is size
I have
1500, isn't it?
yeah 1,000.
Okay, so you've just created an impossible control problem. You've literally just created something that's like several orders of magnitude crazier than like human like solving humanoid robotics zero shot. Can't have like a 1500 dimensional continuous action space like that and expect it to learn anything. The search space of that is ridiculous. I mean, it's like you're trying to guess a point in 1500 dimensional space, and then you're learning that with 1 bit feedback, which is the RL signal.
Mm-hmm.
So, like, there are many things that you can do here, right? Like, and that's not even how, like, usually a Turing machine would work, right? Like, usually you have individual actions that can be taken. Could like, setting an element of the tape is reasonable, for instance. Um, but I think just structurally the env is a bit confused. And then as to why it's slow, well, why is the tape even that big? Like,
I could get it. I could get it a little less.
I mean, I don't
I
even think
mean,
it's like a matter, to be fair, I don't even think it's like a matter of, I don't think it's even a matter of necessarily the tape being too big. It's just in the way that you have the env structured. Um, like you're trying to zero shot the whole thing. Like, is this still a multi-step process if you're setting the entire tape
yeah,
in one step?
yeah. No, actually, it's a multi-step process. So it does it again.
Okay,
So
so here it's like
uh,
quadratic or something because that made it 100. It must be quadratic because I reduced by a factor of 10 and it got 100x faster.
mm,
So you have however you're doing this has got to be like quadratic in tape size or agents or something. Because that's 9 million steps a second immediately.
mhm.
So definitely look at like just the complexity of how this thing scales. And then I don't understand how it is that you have a multi-step Turing machine process where it requires you to fully set the memory of the tape at every step, right?
I actually thought, yeah, yeah. I thought about that. Yeah, I was trying things out. Uh, I mean, I can actually still justify that whatever action it has. taken in one step, it's constant time. That's why I did this. Like I thought that the other thing where I set only a section, a bit to something else, and then move the pointer. That would be. I thought it would be more difficult to learn or something.
The thing that you have here is impossible to learn. Um, like algorithmically impossible. So, uh, yeah, I would suggest if you model this thing off of how a Turing machine actually works, and it's been a few years since I've thought about Turing machines, but if you model this off of how a Turing machine actually works, you should totally be able to RL like move tape, read, write, like that type of stuff you can totally RL. Like that could literally be like a 5-dimensional or whatever. What is it? Like move left,
Hmm.
move right. It could be like increment, decrement by some fixed amount.
Hmm.
I guess read and store stuff. Like, yeah, you literally end up with like a 5 or 6 dimensional discrete action. And then this thing will run. You can even have the full size tape if you do that. And then this thing should run millions of steps per second, and you should be able to do stuff with it.
Yeah. I'll do that.
And then, like, additionally, the observation wouldn't be the entire tape, I wouldn't think, if you did that either. You would make it local. Like, I don't know, if I were
Yeah.
going to design a Turing machine environment, right, what I would do is I'd let it see the tape, like, in some window around it. So maybe it can see, like, 16 places to either side or something like that. And then it can move, it can read, it can write. Um, and then you will actually have a chance of establishing something with this because it'll be really fast and it'll have a small action space, and like just by random search essentially you should eventually stumble onto interesting things. And if you actually domain randomize your problems, you could literally learn like a Turing machine capable of solving a bunch of different like very small small algorithmic problems. You just have
Mhm.
to do it in a way that makes sense for the RL, because otherwise you just hamstring yourself instantly.
Yeah. Yeah, got it. I'll change that then. Oh,
All right, that would be my my advice. Go like rethink about how you want to cast this thing to a problem. Think about having like small Turing machine action space, local obs, not like crazy scaling with size of tape and num agents and stuff. And is num agents supposed to be the number of heads? It's supposed to be a multi-head Turing machine or something?
no, no, it's just the part of problem. Like
Okay.
it's not related to the Turing machine.
All right.
It's
Cool.
just what it's solving. Yeah.
Uh,
Thanks, Joseph.
well, good luck with that. See ya. Thanks. All right. He'll uh he'll manage that if he just cleans it up a bit, and, like formulates it better for RL. You can't just make an arbitrary sim and then RL it is the thing. Like you actually kind of have to. You at least have to design the sim with RL in mind, if that makes sense. Doesn't mean that you can't solve just about whatever problem. It just means you have to cast it in a way that makes sense for the RL, right? Get another cup of coffee, figure out how to load this dang dozer in, and then get GPU drive and Terraform on the website. That'll be a good plan. Be back. Yeah. I get my exercise in. I had the original Turing machine in mind when making this. Then I had the idea of Turing machine generating a matrix. Multiply with the memory tape. O of n cubed, my guy. O of n cubed. Classification. 5 to 6 actions exactly. Also, continuous action spaces suck, and we usually just discretize them anyways. So. Honestly, this could be a very cool environment if you execute it well. Like, you could probably, I could see this type of thing being something that academics would be very, very interested in. But you'd have to do it well enough that you'd be able to, like, solve a bunch of, like, simple generated problems automatically. The Turing machine. That's alright, stick around, you'll pick up more things like this. You also gotta make a visualizer for this thing. It's not that hard. You have a Turing machine. Look up any diagram of a Turing machine and make that. Right? Head is here. Tape goes this way. State of tape. Different colors to represent different values. Or just draw the value in. If you do this well, I'd be very excited to see the results of this. But yeah, it's one of those things where it's really going to be down to the execution of it. I think the idea actually does make sense. Just have to get it done correctly. Have some clarity as well with how you're building this. I think that'd be my new favorite back exercise as well. It took a couple weeks of doing them, but the single arm dumbbell rows just feel really good now. The sets of like 12 with like 70s are good. Felt really bad doing it light for like 20, 30 reps. Felt really bad doing it heavy for like 6 reps. This feels good. So you want to hit milestones? That's the idea with the stream and everything. So, yeah. I'll be able to make it. You'll be able to do it. Yeah, no worries. Just keep the RL port. Just keep it simple. You'll be able to do it. Go think of like the Turing machine examples in textbooks. You know, when they're like teaching you Turing machines, you know, compute, you know, solve this problem, Turing machine solve this problem or whatever. Like, do that. See if it can solve that. DM textbook. I took Sipser's course in at MIT. It was the only mathy course I took. His like discrete math course. It was decent in the sense like, you know, it's not my normal thing, but of course Sipser is Sipser. And unlike in undergrad, I actually had the 20 hours a week that it took me to actually do the material correctly. I did very well in it. I actually felt like I understood the process of the proof-based discrete mathematics for once. I mean, it's a pretty elementary course if you actually do math, right? But like, I could at least see how, I could kind of see how the process worked, and I could kind of see how, the people who come up with really amazing stuff can come up with it, and like the sort of the mental toolkit you build up over the course of being involved in an area like this of research. So that was interesting enough, but I don't know. Pure math is not really my thing. I tend a lot more towards engineering, hard sciences as well. TAI. Cool. Welcome SPY. Material property. Okay, when I upload to archive? Cool. I've not put anything on archive in a while. So actually, the dates. July 11th is camera ready. Cool. Easy. What? Oh, it is there. I'm just dumb. Fuel. Bulldozer. Yeah. I think the dozer is slightly too big. I don't know about you. I think it's slightly too big. So I don't know why it teleports around like that. Is it supposed to teleport around like that? Oh, it's because I'm... Well, first of all, it's backwards. So, it's gonna look way cooler, though, right? Stuff matters, man. You gotta make your stuff look cool. You gotta make the stuff look cool. Viewport, axis. So... Okay, now this is aligned. 180Z. Dozer. Why does it jump around like this, though? Oh, is it supposed to be human controlled? How do I know if this is any good? Looks like a good center point for it, right? Centered there, yeah. A little off the ground. Switch to human. Right. We have more of these, by the way. Like, we have... I bought us this full set. These look pretty cool, right? And especially, you see the digger? Right there. We got digger, we got dump truck. We got steamroller, we got big steamroller. Actually, following our discussion on dirt economics, I realized my family is going to need a ton of dirt in construction soon. So I just said, hey, why don't you guys just dig a pool instead of paying for all the dirt? Just dig a pool. Probably be the same price as not digging a pool and paying for the dirt. Free pool. Alright, where we get... This is human control. We don't have official Windows support, Jason. If it doesn't work with CUDA on Windows, it's because CUDA on Windows is weird. A little high for 10 cubic yards, still dirt expensive, yeah. I mean, they were thinking like they wanted to like elevate a piece of construction, so they have to like make a hill. Like, geez. May as well just dig a moat around it to get the dirt. Where's teleportitis? I would not be complaining because a circular like lap pool would be pretty awesome. This guy mark to skip. Oh, teleportitis. It's still on 400 FPS, so. The keys are reversed, so I assume that's not intended. Models backwards, I guess. Oh, it's stuck as well. It doesn't let me, model prob backwards. Well, it's facing what looks to be the correct direction. I can do it this way, though this seems wrong. Is the model rotated in, Oh, there's no rotating here. It's weird. This. Why does it get stuck like this, man? Moves so fast. Holy. I think I set the FPS pretty low as well. We might have to do, So one of the things did you see how I did interpolation on Breakout and Pong lately? I added this interpolation thing where, well, I guess it's a little different for you. I did it on, Rware would be the good example. But I keep the frame rate high, and I interpolate the movements. That would be a good thing to do here. Set this to 20 for now. Now, see, you can't set it to 20. It looks framey. $30 is min. Good Father's Day? Yes, indeed. Let's puffer some lips. Puff the lips. Funny. Yeah, it gets stuck on the border. Like you end up having to like steer out of it. It's really awkward. Well, like here. So can I even get out of this? Oh, I can get out of this one. Sometimes you can't reverse though. Like if I do this. Can I reverse? See, oh no, I can reverse. That's weird. I couldn't reverse before. Cool. 2 speeds. Should probably give humans the slower of the two. Is it 3 and 1? The objective of this env is to terraform everything. Oh yeah, there you go. Look at that. That's so much better, man. That's like way more doable. Hold control. Yo, that's awesome. Look at that. Nice debugging, man. That's pretty close to the model. It's not centered. Let me see if that's a model problem, though. Nah, it's centered in here. Dude, that's awesome. This should be the screenshot, actually. Like this. Yeah, that's a good screenie. Why didn't you tell me about this, man? This goes straight to the website. It's par for the course. My env work amigo. For the last 2 M's it is, right? You don't have it in Tower Climb. Or any of the other ones. It's kind of cool you independently came up with that, though. Because I had similar viz stuff I would do in my PhD. Okay, where is... GPU drive looks cooler. Yeah, we're gonna get that in next. So, Terraform did not refresh. I go to console, network, disable caching. Yeah. Wait, didn't I? Okay, this thing is caching for some dumb reason. And I made the shader, so I don't know what it's doing. The heck? Oh, did I not? Maybe I did it wrong. Hang on. Yeah, you can definitely get stuck still, man. At least, like, on yourself or whatever. Oh, I know what it is. Dude, I can't take a picture of this because... I don't think I have a print screen. It's at 75% board. And technically I can do this, yeah. Yeah, this is gonna be shit quality though if I do a shot of this. Here, we'll do. Shift. Tab. Failed to open text file. Okay, so those are still the wrong dozers. Those are blue. Oh, because it didn't run. Takes a while to compile. Kinda weird. Oh. Well. Dozer's here. Dozer's here. No valid shader program. Okay, let's see what shader it is that's breaking. Shader. So the target loaded successfully. That does anything. Matches the given URL, really. There. Fragment shader. Yeah, okay, there it is. So it's in the fragment shader. Float declaration. There. What the heck is this? Hey, Tosin. How's it going? If you have Robocode doing stuff, I can merge things today. It'd be fun. For a wedding, flying back in today. Alright. Busy then. We're getting all the new M's onto the website. You can see, well, that one's not done, but you can see all the new M's here. Haven't done the full code review yet because you said it didn't. You didn't have any like nets training or anything on it, right? How's GPU situation? I have the GPUs working and stable. It's gonna take me some hours at some point to put all the cases back on. But check this out. This is super linear, state of the art on neural MMO with 400 billion observations trained. I don't think a run of this scale has ever been done on this little hardware. That's pretty cool. couldn't get the Docker working, yeah, let me know on that. I can help you figure that out. That is something that you should know for just your PhD in general. It'll be very useful, though. UV has gotten like kind of fast to where you can just set up with UV now, but there's still some things where Docker's just nice to have. What's wrong with Terraform? There we go. Rock was dumb. That's the usual culprit. Also, this is a really good aspect. Like, this 720p for the ends has been really good. Do this. Bulldozer sim. Yeah, you can definitely still get stuck. I gotta tell Spencer about that. Ah, this would be press. fuel though. And Spencer, did he send me a map? A map. Okay, Spencer says send me a map for GPU drive. Load that in. And after that, I think we'll just start looking for. Well, we'll have to start collecting all of the videos. Figure this out in the meantime. Yeah, they just friggin' broke the badge. This thing not just have one? Discord should just have a... server settings. It was good. I'm a car for this, I'm sure as well. Where do we usually get models? Sci-fi car. Pixel art. Isometric cars. These are 2D. 2D. Thank you, Spencer. Let me get first. What are these? We got spheres rendered around all the cars. I wish I could just get us like a better frickin' car asset. Surely there's got to be some like cool cars, right? R3. This should be big enough. 3D models are crazy. Oh, these drones actually, they have some good drone models. I'll get this on the website and I'll leave it up to you if you want to tweak assets or visuals or anything. I don't know. I think I kind of like the Tron vibe for some of this stuff. Where's the the show lines button, man? Oh, this is cool. Shift. Cool. Shift hides everything else. Can we not make it hide everything else like this? Hang on. We need to get a good freaking screenshot for this thing, man. It's 99% of the way there, but it looks like a third as good as it should. Yeah, but it's gonna look really freaking cool if you can see the full road with the overlay like that. Where is it? Where's the thing that disables drawing? If you have, was it shift? Okay, so we just do this. You don't need to remove the geometry. You can still tell because of the lines what it's seeing. Not down. Oh, wait, if that was the goals? Hang on. Well, remove the goals, right? Here, well, let's just... What the fuck keeps happening to this thing? Okay, maybe I borked it. Yeah, no, it's like because it collides instantly or something. Which cars? I thought you could switch cars with the arrows. Like, I thought you could switch cars, though. Okay, there we are. But I'm still not driving it. It's driving itself and it's crashing into shit, right? Also, this is... Agent Obs. Okay, what is just chill out and don't do anything as an action? Alright, I will let you sort that. Let me just fix this at least so I can get something. Trying to figure out where it actually, like, stops it from drawing shit. Probably this, right? Yeah, this is it. Okay, so we do like this. Yo, what are those arrows? What are those arrows? The arrows at the end of the lines are like going nuts. They're like phantom cars that are just spinning there. Yeah? Like there are no cars there, but they just show us they're spinning. Are dead cars still taking actions? This should be like 4. 7, right? So it's like 4. This is like 7. No, it's 3, 6. Yeah, see ya. Binding for Vizdoom been done before. Would it be any faster than Sample Factory? We technically do. If you check, there's an old one, and it will give you some warnings on like files you have to move around. I briefly did a thing with Vizdoom where I found out that there was an unused render setting that lets you render at lower resolution natively than most people had tried. And if you do that, I think I got it to like 100k steps per second. So you probably could do something with that if you're interested, and it would be a very cool environment. It would still be like an order of magnitude slower than even our more complex puffer ends, for sure. Unless you found a way to get it to like not render or like yeah, there'd be some hacking basically with it. There would definitely be some hacking. It could be very cool, but there would definitely be some hacking. I will say your Tetris env looks awesome. Like that's now one of my favorite of the ends. Like just look at this thing. Oh, it does flip by the way. It flips very fast. I watched it for a bit. Hang on. Look how awesome your env looks. This is how it's going to show up on the website. That's cool, man. Drone is ready to go. PR is live. Give me 5 minutes, Sam, and I will go through the whole thing with you. I just want to finish this last thing that I was doing here. Should be. Sample factory reports a 300K raw. Was that on a 64 core 64 core CPU? What was that on? Okay, this is what I had to get. And then hopefully... And then did I make... I think I already made this thing. Yeah, look at that. Add docs real quick. .36 core raw sim, 300K. PPO 100. There's no way that they get PPO at 140K with a non-trivial policy. Like, just based on the numbers. Unless they're doing some weird thing. It's still no. Like, maybe if they have it downsampled, they could have it downsampled to like 64 by 64 or something, and then maybe. We're kind of at the point where most of our stuff is now like faster than Sample Factory was. So like, yeah, you can probably beat Sample Factory with our infra. But it's just, our stuff is all designed to be an order of magnitude faster than Sample Factory. It's just we haven't used any of the envs that they've tried to speed up because they just bottleneck so hard on the pure sim. I mean, like, if you get training in the hundreds of thousands, at least, then we can do something. But, like, even then, so for, like, multi-GPU training, for instance, right, you immediately run out of cores. Because if you're bottlenecked by the sim, even on 32 cores, then you go to 32 cores, 6 GPU machine, and you're still screwed. You can't do anything with the extra GPUs. That's the real issue. Like, we have this result right here. This is 400 billion steps into training. This is Neural MMO3. This is a SOTA result, and this is like probably something like this has not been seen since 2019 era OpenAI. Yeah, and this type of stuff is just enabled by having FastSim. And it's like FastSim on the scale of there is literally no infra you can write to make that thing faster unless you specifically go into the Doom code and like, I don't know, you'd have to extract state-based obs from the Doom code. If you could get that, then you can probably do it. If you could make Doom return like state-based obs, you could probably do it. Okay. The only thing I wanted to do before I forget and then look at drone is WA. Something is weird with so these controls are backwards and non-continuous. Let me do let's go look at the drone stuff. All right, Finn, what you got for me? $906. Perfect timing for 3.0 as well. I stole a little bit of your quaternion math as well. Because we have, I mean, this is like way worse physics, but we have this thing. And you can see, I mean, there's no policy on this, but you can see all the planes and stuff spilling out of here. Ideally, we're going to get some real physics on this at some point. Let's see drone M. You're here, right, Finn? Because we can go through this right now live. All right, awesome. Yeah, there's so many M's. I've like to give you an idea of the last few days. Look at all the M's I've gotten onto the site that had to be built. So this is 2.0. All right, this is 2.0, and then this is 3.0. All the M's. All right, let's take a quick look. I can hop into the Discord as well in case questions. If you want, we will see. But I will start looking at this code either way. Both join? Awesome. Yeah, this is some good work. I will say that that new like battle simulation, it only took me like 4 days. A day and a half of that was like banging my head against the basic physics of it. The physics is such a pain. Let's see what we have here. We've got drone, we've got some likely swept hyperparameters, it looks like.
Hello.
Hi, Joseph.
Welcome. Congrats on being done with exams. I do not envy you one bit on those.
Thank you. Thank you. Thank you.
Yeah, thanks.
Yeah, those kind of just suck. All right. We've got Presumably, this is initial orientation and angular momentum and everything. So you have full initial state.
We can't see what you're looking at in real time, but
I will share it on Discord, and then there will be no latency.
Okay.
That
perfect.
sounds good.
Another perk of this. Mute stream, otherwise, you know.
Yeah.
All right. Let me
There we go.
just. Okay. So you have full initial state. It looks like as part of the env. Yeah.
Yeah.
Yes.
This is position velocity, orientation, and angular momentum.
Yeah.
Okay.
Well, angular velocity, but yeah.
Angular velocity. My last physics course was 12, 13 years ago. I don't know.
Fair enough.
I'm brushing up on stuff. I'm starting to do a lot more. I don't know. I've been like going back through really old courses, trying to like, you know, because we're
Mhm.
trying to think how, like what we can apply this stuff to now that we have all this cracked out RL.
Mhm.
And drones is actually a very good opportunity. So there's probably some stuff around Puffer to do with drones.
Yeah.
Mhm.
Yeah, we'd like to make it multi-agent at some point. Maybe like a tag environment or something like that.
I mean, right now in this thing here. I mean, I don't have. I gotta like actually make this thing. I call it school. Right, that thing will train for a bit. And I'll show you once this thing is. It looks really cool, but the physics suck in it so far. But we're thinking of doing things like that. There should be a lot
Can
of
you
folks.
see?
Can I see what?
Sorry, can you see the stream, Finn? It's
Yeah,
it's
yeah,
just
I can see
buffering
it.
for me. Oh, okay. It's just me then.
Ah.
Never mind.
Based on your mic, I think it's probably connection.
Oh, really? Is it not good?
It's like
Your mic
dropping some packets or whatever. I think.
All right. Okay. I'll
is fine with me. Maybe it's a
so far
transatlantic
away.
thing.
Huh. Okay, that's weird. I wouldn't think I would be having any streams at 5. Yeah, streams at 6K. Well, regardless, let me know if anything that you miss here.
Okay.
So is it system load? Alright, whatever. I think it was actually not your mic. I think it's that it's my system's running at full because I launched this train job.
All right. Okay.
Alright, that'll
Yeah.
that'll be done in a minute anyways. But okay, so we've got random actions in the C.
Mhm.
Got the new style allocations. This is like very, very new style allocations. That's nice. Saves me time from refactoring. I never even do these checks because like if you can't malloc stuff, you're kind of screwed anyways. But sure.
Yeah, we haven't looked at this file in a while, so should be
Fine.
fine.
So yeah, like this is I never really do this in the C because it's like yes, technically if you want the program to have a 100% chance of running without errors, you do this, but it adds like a ton of lines, and it's literally like the only time this fails is if your system's out of memory.
Right. Okay.
Hello.
Hello. Let's see. So this is gonna be the big file. We'll take a look at the other one first. I did steal some of this plot math, and then I realized Raylib has you know, Raylib actually has a lot of the plot math built in.
Right. Okay.
Yeah, we were getting some like naming collisions, I think, but
Yeah.
we sort of went with our own stuff.
I went with my own stuff first. I think it is equivalent, to be fair, but it is nice. The Raylib stuff is the same, and also it doesn't depend on having the rendering up. So, like you don't actually have to init Raylib. It's just kind of the same thing as a standalone. Oh,
Yeah.
Okay.
this ran by the way. So here you can get a sense of the multi-agent. This is not even a particularly good model, but just to give you like a little idea of what we can do with our RL now. Right.
Nice.
1000 agent.
That's a lot bigger than it was a couple weeks ago, or maybe a week ago.
I think hang on. Yeah, there, camera. Sure. Yeah, 1000 agent battle environment. You'll actually see if they get too close, the lasers going off. Yeah, there. Zap.
Very cool.
Zap, zap. So yeah, this thing has the drone dynamics suck in this because I didn't port the full things over, but this is like air to air, air to ground, ground to air, ground to ground, separate units, like 6 different types of separate units. Yeah, so this is the type of stuff we can do with a little bit of control in Puffer now. So I'm pretty excited about this drone stuff.
Very nice.
Plus, did you just
Is
see
it quite-
the order that was signed a couple days ago to make make it a lot easier to do drone stuff in America?
No.
No.
Apparently, yeah, this is like literally the the drone boom is about to start because of that.
Yeah.
Well, that's good timing.
Yeah, it's very good timing.
Nice.
There will be stuff in here. All right. Massive init, all these args, cool. Do you set the initial state? Like
We do in reset.
Yeah.
Is there a reason though that you have the full initial state specified from Python?
I think that was just the way it was done in one of the other examples.
Oh, okay. Yeah, so you only need to specify like stuff that you want to be able to change in the config, right? So like if you wanted to be able to specify the full state from config, then you would do this.
Right. Okay.
So could
It's
we
not
bin
going to
that
hurt
from
anything.
binding.c as well?
What's that?
Could we remove it from binding.c then as well, or is that?
Yes, you could.
Okay.
You just have to
Excellent.
you have to init it somewhere. So if it gets calced and you want it set to 0, you're good. Otherwise, it goes in init.
Right.
Yeah. So now we have this is the single agent invocation. There's actually like a single like a one-liner that you can even do for this. For a single agent, but when you're going to multi-agent, yeah, it'll look like this anyways. Fine. Yeah, this is like a correct basic binding. It's fine. Check this, and then we'll look at the main meat of this. Policy real quick. So small.
It's just the default policy, pretty much.
Oh yeah, if you just have the default policy, you don't even have to mess with it. You can just like policy, like just set policy equal policy.
Yeah, I think we were messing with it originally, and it kind of
And
just
it just
didn't
ended up being the same.
Yeah.
Yeah.
Well, I'll see. I will look and see if I have anything that's iffy with that. Oh, the one thing I wanted to check was the action base. Okay, so you do have it being continuous. One of the things I've been thinking about, and one of the things that might make training easier, we haven't done full experiments on this, but so far it seems like discrete has just been way easier to optimize than continuous. So one of the easiest things we could do here is like change this from box of 4 to like a multi-discrete of 9, 9, 9, and 9, and then you just discretize the 4 motor intensities to like 9 values, and then possibly it could be a lot easier to learn, possibly not. But yeah, that's like definitely worth doing. And then if you do that, you have to remember to change the types because it becomes int, so the action space has to become int. But yeah, that's it. Right.
Right.
Let's go to the main meat of this. It's not that bad, 540 lines. A lot of it's quaternion math as well.
Yeah.
Yeah. It will be.
Well, I think only a couple hundred is drone. The rest of it's just like PufferLib stuff.
Cool. So we've got. Yeah, this is the exact type of thing that I was like looking at having to do for my new sim, and then I went, that looks like hard physics.
Yeah, this took a bit of experimentation for sure.
Well, you're doing it at a good time when you're actually like you've recently done some stuff at least in undergrad.
Yep.
It's like there are a lot of these things that I could have done 8 years ago that it's just like I have not done that in forever.
Yeah.
Right, you got your basic math. Yeah, I remember reading all this stuff. What? I had a fun time reading a bunch about quaternions, building the schooling them, so I'm perfectly up to date on all this crap. Client. Types are good. Grand time of no, so that will this right here is probably a bad idea. And the reason for that is this gives you time in seconds. And
Mhm.
so this is going to call a knit. This is going to get called on each environment, right?
Yeah.
Puffer's really fast. Those are all going to init to the same thing. Because you call
Okay.
srand every time. So I recently added, I think it gets done for you. I have not rigorously tested this, but so here, we look at what's this nvinit. Okay, srand will seed to this seed value here, and then yeah, you just pass, you pass a seed argument to this, so it'll srand, it'll set it to a different seed every time.
All right. Okay.
But like you can pass the seed from your .py. I think you have this in here, right? When you init with the .py, I took care of it for you for this exact reason.
Mhm.
Seed right here. So this seed just like increment by 1 every time instead of just passing a static thing. Yeah,
Okay.
and then you should be good. All right, so that's one thing to definitely do, because that can really mess with stuff. Do you do like obstacle generation or something?
Not yet. No.
We
Cool.
had that in the original Python environment, but it makes the maths a lot more complicated.
For like collision?
Yeah.
You can't just treat the drone as a sphere and like, radius.
Well, then you have to treat the colliders as spheres as well, right?
Oh yeah, you have to do sphere box collision, I guess, right?
Yeah.
Yeah, that's slightly annoying. Yeah, it's slightly annoying.
We originally did it with like vector projections and stuff, so it's not crazy, but it is
Okay.
probably another 100 lines or something.
Yeah. Now there will definitely be opportunity for stuff. We're trying to figure out what to do in the drone space, because there's like the racing stuff, there's like defense stuff, there's tons of different areas, and we're kind of trying to figure out what we
Yep.
want to do. And we're looking for more industry stuff because the wall of servers behind me does not pay for itself.
Yeah.
All right.
What's the cost per box at the minute?
I mean, the individual desktops, that when I first started getting them, they were like 4K, and then they went up to like
Right.
5.5, I think, for one of the more recent ones I
Okay.
bought. If I want to buy more, they're quoting me at like 7K now, which is ridiculous. Because of
Yeah.
and then the tiny boxes are 25K each. So those are fun.
Yeah.
So yeah, like 100,000 bucks worth of hardware. But it is very fast. And
Yep.
if I were to
That's
rent,
for sure.
if I were to rent like an 8X H100, it's not even really that much faster than the tiny box, like at all.
Yeah.
That would be $100 per day.
Right. Okay.
Oh no, I'm sorry, $100 per day, $200 per day from the best provider.
Okay.
Second best provider, $400 a day. So like the hardware prices are just
Right.
like they just make up numbers. It's crazy.
Yeah.
Assume the logic is below this. Rotor offsets. Oh, do you draw the rotors?
Yeah, we just
Yeah.
draw little spheres sort of positioned in a cross around the central sphere. There's a video on the
Oh,
dev.
you made the okay. Well, I'm gonna run this afterwards.
Sure.
Maybe I should have I got a quadcopter model I can give you, like.
Mhm.
Oh, okay. I see what you did. Okay, cool. Yeah, we can totally get you a quadcopter. Yeah, this thing behaves like way more realistically than my drones do. So that is
Mhm.
solid.
Yeah, that took a while.
Yeah.
Yeah, that's definitely solid. And I think that like right
The-
after we release, pretty much right after we release, I'm gonna be doing a lot of like drone stuff personally, a lot of my time. Welcome,
Mhm.
Major.
Very cool.
The first iteration of the physics was a bit crazy. It was just doing like barrel rolls and stuff and like just flying upside down, but managed to fix it since then.
Yeah, yeah, it's well, also we'll get you the nice quadcopter model for it and stuff as well.
Mhm.
Then I think just generally this whole like kind of like a 4-point thrust model, didn't you?
Yeah.
Yeah, so that type of stuff in general, if we can just figure out, because I don't want to go to like a full physics engine, they're so heavy and so annoying. But like if we can
Yeah.
just figure out like a
Totally.
basic like point mass thrust model, like that would unlock a lot of control stuff for us. You know, like that's
Mhm.
kind of already enough to get like a bunch of different vehicle types and form factors behaving like better than most basic game physics.
Yeah.
Wait, what? That's it? Where'd the logic go?
Which logic?
The actual. Oh, I totally just skipped over the actual.
Yeah, it's just really quite short. It's not.
Well, I skipped
Not
over a
crazy.
lot of stuff somehow. Okay, here's your quat math. This I looked at. Nicely normalized observations. Good. What maybe normalize? No, is it unit?
It gets normalized later. Yeah. It's
But in the obs. Well, I don't know what the max value.
um
I don't know what the max values are if they go up to like just pi or if it gets more.
yeah, no, after every C step we normalize it
Good then.
again.
Yeah, then this is well done. This is like what you want. Perfect.
Nice.
And
What are your thoughts on clamping the actions between -1 and 1 at the top there? Is that just fine?
yeah, you can do it. You're gonna deal with continuous jank for now. That was
Yeah.
my one big suggestion was to discretize. So discretize and RNG are the two big things so far. That
Okay.
actually could make a big difference. Because
Mhm.
like continuous, what we've seen, there's a whole bunch. Have you seen like unstable training with NANDs? Or no?
No.
Okay,
No.
well then maybe you're just good. But in a lot of continuous things, we see like just stuff gets out of whack.
Mhm.
And we don't know if it's fundamental or if like there's a way around it. But like so far, our best results on M's have been with discrete. Also,
Right.
pet peeve: don't use tabs. And this is not just a me thing. Like everyone will tell you, don't use tabs.
I thought you
Oh.
said last time you liked tabs. I changed it to tabs just for you.
Wait, what?
Okay.
Who the fuck
Well,
tells
I
you?
think we
No,
had like yeah.
no. It was spaced. It was
Okay.
because you had it two spaced. I said use
Yeah.
four spaced. So when I think I said use four spaced tabs, which means use tabs that like when you tab it expands
Yeah,
to
yeah.
4 spaces.
Yeah. That's fine.
Yes. Okay.
I can fix that.
No. I did. There's this funny result that everyone cites whenever you post code with tabs, which is there's
Yeah,
there's
yeah.
this funny statistic that programmers who use tabs make less.
Okay.
Don't use tabs. But no, the real reason
Yeah.
that you don't use tabs is because they're really easy to screw up and mix with spaces, which is really annoying.
Yeah.
Right.
So everyone just sets tab expand.
Yeah, it was all spaces before I just
It
did
was two
Clang
space though,
format
wasn't
on
it?
it. Yeah.
Yeah.
Yeah, so that was the
Yeah.
thing. Yeah.
I don't
Alright.
know why it did that, but
Yeah.
I can sort that out.
Yeah, just change that. It's easy. All right, and now body frame. I will merge this though before I make you do that because we should get this into that repo.
Epic.
Nice.
Very epic.
No, I've been so tempted to like buy some quadcopter parts and start like soldering stuff.
How much are they nowadays?
Less than servers.
Okay, fine.
But I do remember that they sometimes are quite difficult. I remember I had a high school buddy who ordered like a really nice one. It's part of like the robotic stuff he was doing, and it was like impossibly small to like solder stuff. Like nobody could
Right.
actually solder it.
Yeah, we've managed to stay well clear of that so far.
We have to get this running on a real quadcopter, right? See if it works.
We have tried, but not with a very good quadcopter, so it didn't go very well.
I actually think I know how to help you with that. Do you know how domain randomization works?
It was
There's a
just
span.
the drone we had was so bad you just couldn't read data from it fast enough to.
Okay, that'll be an issue. But if it's the
Yeah.
physics, you know how domain randomization works?
Is this like randomizing the parameters of the env?
Yeah, including
Or-
the physics. You jitter the
Yeah.
laws of physics a little bit. Like you can jitter acceleration and jitter like what happens. And the idea is you end up having to learn a ridiculously robust policy. But whatever the heck the conditions are in the real world, you're just good. Now this doesn't work like on its own perfectly for stuff like humanoids, but for quadcopters with like its
Mhm.
0 degrees of freedom yeah, you're totally good.
Mhm.
So
I'm just about to push up the fixed indentation. If you
Cool.
hold on a sec.
integrate quaternion. What? Hang on.
I don't know if that's the correct terminology, but
Let me actually
it
make
does the
sure.
thing.
All right, so
Does the thing.
thrust, force, Vec 3, F body. Why is this applied in the plus Z, or is this plus Z in the local coordinate system?
That'll be Z in the drone, like the drone coordinates,
Okay,
which we've defined as up.
gotcha.
So
So it's in local coordinates, then that's correct.
yeah,
Arm length times force difference. Okay. Okay. I see how that works. Angular damping. And yeah, this is really nice. This is the exact type of thing I was trying to figure out how to do. This is just really well done.
cheers.
Thank you.
If we could figure out how to make like an easy way to just apply this level of physics sim, like a couple different form factors, we could do a lot of stuff with this. Heck, even just the drone, like the one quadcopter drone form factor is already pretty dang good.
Yep.
I can very easily show you how to like apply randomization and stuff to this as well.
Nice. Yeah, we've got plenty of time this summer. Well, enough time.
Awesome.
Good to go.
That's awesome. Yeah, this is perfect timing as well because we're very much like we are looking to do stuff in drone space. We're still trying to figure out who we're gonna like pitch stuff to, but yeah, they're like we could definitely figure something out with this.
Nice.
I've just pushed another commit which fixes all the indentation.
Thank you. So from definition of dot,
Yeah, you
This-
just times by half for some reason. It just it's
probably
the thing.
so this is the that you is this acceleration? Is it? Accelerations usually get wait, 1/2. No, V gets an acceler. Squared velocity gets acceleration because second integral, whatever. Okay, I see what you mean by integrations. This is just a
Yeah, that could
Yeah.
maybe be improved, but it's fine. It
Yeah.
does the job.
This type of stuff usually gets to be unstable, I think, in long sims, but RL is self-correcting, so like maybe this just works.
Yeah, we found with even like massive DT, it was just fine. It just kind of did its thing.
Yeah.
Yeah, because I mean RL is just self-correcting. So like
Yeah,
the question will be the sim to real gap, right?
yeah, for sure.
I don't know. Remember to reset top. Did. Implicit Euler can be unstable. Yeah, I'm aware of that. I don't know if you need RK4 for something like this though, because like your goal is not to have a system and then just run it for many steps and have it match the real outcome. You have a self-correcting control system. So I don't know if you need something like RK4. Like you
Yeah, I mean,
technically
if that's
might.
needed, it wouldn't be a big change anyway. So be fine.
I just don't want to have to look at the map.
Yeah, fair enough. We can do that.
It's one of those things where like I know I'm gonna have to go back at some point and like just relearn all the math, but it's like my brain has just gone so far in the direction of building shit. It's like a very different skill. It's a very different skill set. Like, what do I think of all day is like, how do I take incredibly complicated system and make it as simple as and fast as possible? That's basically all I think about all day, which is very different from the formalism.
When do you think 3.0 will release then? Is it sort of a couple days?
It's gotta just be done. Like it's just been so much work. I think at this point we're getting all the things on the site. I'm going to today attempt to find somebody to cut me together a trailer. I don't know where
Okay.
I'm gonna see maybe Upwork. I gotta find somebody who does like trailer like intros for YouTubers or whatever. I want somebody who will like work with me just to find some cool way to present this stuff. Like I give them all the clips of the environments. They'll find like some way to cut together like a 30-second trailer thing for this, and then hopefully we get a lot of eyes on this. Because like basically at this point, I've worked on this for over a year, pretty much double time. Yeah, it's this last few weeks in particular have been nuts. We're in a decent enough position where I can like maintain servers and such, but I want to be able to grow this to where I can be like actually bringing more people on, and having this be like a proper private research lab where we're really really accelerating the field. So for that, it's like I gotta find ways to like get more eyes on and find some bigger contracts for us. That's kind of the next thing. And hey, drone space is definitely one of those.
Yeah, that sounds super cool. I can't lie.
Well, I think we're in if you want any help with anything.
Absolutely. I gotta figure out in what
Yeah.
capacity, but I already, as soon as I saw like the quality of this code, I was like, all right, I gotta figure out what capacity. But yeah, we should do something for this.
Yep.
So-
Cool.
Like it's kind of on me to like first actually get a formal contract before I hire people or like pay people for a specific project. So I gotta figure that part out. But then yeah, we can do something with this.
Cool.
Or drag. Render. Actually, I do want to see on the rendering how you did. Yeah, because there's this annoying thing where you have to like redo. You have to like redo the calcs, right, in order to figure out how to render it in world space, right?
Yeah.
So yeah, I had to deal with this as well.
The Raylib code is probably the bit we're most unsure on because it's not the first C code we've ever written, obviously, but it is the first Raylib we've ever written, so it's a bit trickier.
So with this thing, I think I might have actually found something that can help you.
Mm-hmm.
How you're doing the route setup. You have rotor offsets. Where do you get the orientation? Hang on. Raw sphere. And where do you get the... Okay, you just do this plot rotate. This is actually fairly clean. So the way that I did this, I'll show you. This also took me a while. Like, I know that this stuff is annoying.
Yeah.
You want to see a big env. So admittedly, this is way larger than it needs to be. I did this like a couple weeks ago. It has all these different units. And got the quant math in it. The way that I did this for, yeah, this is quant math with the Raylib one. Heck is the render. Okay, so all I did is I did a quaternion to matrix on the orientation, which is the quat of the model, and then I just set the transform.
Yeah.
So this ended up being super easy. Everything else I tried would just like screw it up, and like it looks like you did get the math there eventually, but something like this might be easier. Actually, I'm gonna be honest, I wasn't 100% sure about using the Raylib math functions because one, they're kind of verbose, but also like, you know, if one of them is slow for whatever reason, then it's like I'm gonna have to go rewrite a bunch of crap.
Yeah.
And I don't know. I think I looked and I think that they use float 32 default, not 64. It's like it's reasonable, but I don't know if there's anything in there that like needs to be improved. So I'm not 100% on just using the Raylib plot math. I would be equally happy just making our own like standalone quaternions.h
Yeah.
or whatever, if that's the way we want to go. Like basically just take yours and add a couple extra functions, and we could just be good there. The only thing is we would have to output. We'd have to have like something to output this Raylib transform. I think that's like the easiest way to draw it, which shouldn't be that hard. It's just like this is just like a super basic data structure if you check the source for it, right? And then okay, yeah, let's go run this and see what we can do here.
Cool.
Fresh. Super solid env. This is like, I don't think anybody has submitted me env code this clean on their first PR. This is quite nice.
Okay.
Yeah, this is very good. I mean, even like if you've seen some of the stuff that Spencer is doing now, like he's building awesome stuff. Go look at the triple triad code. if you want to see like
Mhm.
the delta. So it's very impressive to be doing this on your first PR, especially like I don't think I ever see this type of stuff from undergrads, like ever. So well done, very well done.
Thank you.
Cheers.
We really enjoy this stuff. Pretty much every waking hour that isn't uni work is spent on reinforcement learning.
Hey, I'm trying to make all this stuff easier. I will here. You know what?
Yeah.
Let me just give you a sneak peek of like I got something that's pretty darn cool.
Mhm.
Now I think actually the model's gotten better since I pulled it, and I have to reduce the frame rate, but this is something that took me 8 years.
I'm still slightly behind because I'm on the stream. Discord's not having it, but
Mhm. Yeah, I think we both found you through your thesis defense on YouTube.
yeah.
So
With,
this thing here, this model is trained on approximately 4,000 years worth of gameplay. It
Mhm.
is
Wow.
better.
Okay.
It is better
Yeah.
at the game than I am. It is like
Very nice.
it actually knows how to use and like equip and buy and sell to some extent equipment.
Mhm.
It knows how to like pick its fights because there's enemies that are too strong for it and enemies that are not.
Mhm.
Yeah, this is like dramatically better than anything I did during my PhD, and this thing trains in like 200 billion was 2 days on the tiny box, not even.
Wow.
Yeah.
So about 2.2 million steps per second training on the 6G.
Wow. Okay.
Yeah, and the impressive thing about that is that it uses the local CPU. So the CPU's
Mhm.
it's designed to be fast enough that it can actually serve that amount of data. Just using the local cores, which is the key thing. Because Neural MMO2 during my PhD ran like maybe 1,000 steps a second per core. This thing
Yeah.
runs a million plus.
Well, I think
How mu-
even when we first wrote Drone in PufferLib, like back the original iteration, I think we went from about 2,000 to a million steps per second or something like that. It was
Yeah.
ridiculous.
And I've worked on making it easier and easier. And then like this environment, when I made this was one of the first things I did after graduating. It just didn't train.
Mhm.
It just didn't train well at all. And then kind of just
Yeah.
like over the course of making the algorithm better and better and all the improvements we've made, this is just like a slightly bigger model now trained for longer, and it just does this. Um,
Yeah.
yeah,
Yeah, it is super cool. I can't
it's
lie.
not like totally genius yet. Like it, for instance, I think it has a better bow in its inventory right now, and it doesn't realize it. Um, but it's also like I suspect that the observations could be structured way better than they are right now. So,
Mhm.
like,
Mhm.
yeah, this thing is very quickly going to be like this environment. I think as is at least as complex as some of the stuff that was being done OpenAI and DeepMind in 2019. Like not AlphaStar or Dota, not that complex, but like Capture the Flag or
Yeah.
Hide and Seek, absolutely that complex. And we're training it for
Nice.
like comparable or more data than those projects trained on, but we're doing it on like 6 GPUs instead of 1,000.
Yeah.
Yeah, that's slightly insane.
So yeah, this is where RL is going.
How much more performance do you think you can squeeze out of, this current stuff?
Mhm.
Probably quite a bit if I tried. Probably
Okay.
quite a bit. We still
Yeah.
have there's so many more things I can do. But I think that the next thing is going to be like to try to make this work on a few real problems first, just so that like I mean
Yeah.
like we have the training like this type of training is just not a thing that happens anywhere else in the so we should be able to
Mhm.
basically infinitely fund all this research, and once that's settled, we can kind of just like optimize the crap out of everything.
Mhm.
That's the plan.
Very nice.
All right, so what's it called?
Uh-oh.
Oh, I'm done. Okay. Try to steer it or not really? Alright, cool. And we do. You guys do AI stuff outside of RL first?
Yeah.
Yeah, a little bit. A little bit.
Say. It's
Mostly
not
IL.
an easy subfield to jump into. Like I did NLP stuff, I did language modeling before Transformers, like before Transformers were a thing. And then I did
Yeah.
what else I do? I did some like weird like dynamically assembled vision architecture stuff. And then neural MMO
Right.
was kind of just the big thing.
Well, this summer we're trying to kind of learn the ropes of research. We've got at the university like a position to do some language model reinforcement learning stuff, which should be cool.
The LMRL stuff is tough because like you don't get a million step per second training.
Yeah.
Right? Like
That's-
all the
that's pretty
things,
easy.
they're like all these things that language model people are like slowly discovering. And they're like discovering them like slower than we are with our tiny amount of resources, just because like we run a million times faster than the
Yeah.
language models. Right?
We're hoping and praying though that once we start next week, we'll get access to the department's H100s that we're currently locked out from.
Get some super compute.
Yeah.
Yeah. This thing actually trains for quite a while, huh?
It maxes out at 5.0.
So why is it set to train for so long?
I just it's just a big number. I don't know.
Yeah.
We didn't
Alright.
use that for sweeps, but
You may find you want to sweep again because we were running it on the like student GPUs, which aren't great and can't last very long because other people are trying to use it as well.
Is there no ini file for this?
there
No
should
ini
be.
file. Get one.
Oh, it should be.
It was training remarkably well for not having a.
Ah, it's in the wrong. It's gotta go into Ocean.
Oh, okay, yeah.
Oh, did I put it in the wrong place? Sorry.
We do anything that gets like submitted as a native puffer to Ocean.
It was in
Yeah.
the right place before. It was just we were many commits behind on my local copy, so I had to do a bit of messing around with Git.
Yep.
I clearly messed it up somewhere along the way.
Yes, so you've got n of num m's, you've got drone. We have total 1 billion total time steps.
Why not? Why not?
Okay, not 1 million either. I can't read.
Yeah.
Update. Oh, this is no R and N as well. That's funny. What?
Do you think it would benefit from it?
I find it pretty amusing that you're doing this with a 2,800 parameter model.
Yeah.
Mhm.
Just what?
Wait, what? What? All right, to give you guys an idea here of how ridiculous that is. You see that 800k steps per second? That's on CPU.
Yep.
Right. Okay.
So that network is so small that even if I put my 4090 on it, it's not that much faster than the CPU.
Mhm.
Right, let me try something here, because that's silly. That is just silly. Right, let's actually here, we'll get a baseline first. We'll see if I can improve your drone model at all, because it doesn't look like it's perfect yet.
No, it definitely isn't.
Well, you have
Yeah.
two. All right, I'm going to teach you something here. So, you know how? Did anybody ever tell you about like local minima in deep learning?
Yeah.
Yeah.
Okay. Now, did anybody ever tell you that that's a lie?
No.
Okay, so there's this whole kerfuffle here. So we'll give you a history lesson. Old man Suarez, he'll give you a history lesson. So in around like 2015, there was this whole kerfuffle where like people were just like worried their optimizers just weren't working or whatever, right? And the idea was that hey, these are massive non-convex optimization landscapes, and you're going to hit all these local minima. So there was all this research on that, and eventually there was some fancy paper that came along and said, hey, actually local minima just don't exist.
Right.
And the intuition for
Right,
this
okay.
is very simple. If you flip a coin, heads or tails. Every single dimension, you flip a coin heads or tails. If they all come up tails, then you're stuck in a local minima. Right? Because you can go in one direction or another. The derivative can be up or it can be down. So they all have to come up heads. Now that's not true because that models them as like completely independent, but in practice it ends up being a good enough explanation. So, you know, you just can't get local minima because there's always going to be some direction on which you can improve. Now, if you go from 1,000,000 dimensions down to a relatively small number of dimensions, you get local minima again, and you get non-convex optimization
Right.
hell.
Okay.
So this
Yeah.
is why, in general, we don't use dimensions that are lower than like 128, and we at least use neural nets that have more than 2,800 parameters.
Okay.
It might not be
Yeah.
that bad because, like in this case, it's like okay, whatever. It's 128, but it's just a 2-layer network. But now you just don't have any representation capacity. You literally have one hidden layer. All right, so you can
Yeah.
represent one nonlinearity's worth of interestingness. And technically, a 2-layer neural net can represent anything, but only if you make the hidden dimension exponentially large. So that's some academic bullshit.
Yeah.
All right, let's see. Let's see if we do RNN name. Do this. Do this. What happens? And not C. I literally trained that on CPU because I didn't even notice the difference. Okay.
I'm going to quickly swap over to my phone in hopes I
Mhm.
can see this stream. I'll be 1 second.
Okay. So we've got 130,000 more parameters. Wow.
And it's not any slower, is it?
No.
Booyah.
Not really.
At least not on a 4090. We do see some unstable shenanigans. Doesn't seem like it's getting to full solve.
Yeah, true.
A 5.0 at least. Sometimes
I
I
think
don't
what can
even
happen-
use the LSTM because of the memory, like all the time. Sometimes we just use it because it has like a few extra non-linearities, so it's like, better than nothing.
Yeah.
Come on, drone. You got this.
Do we know what max score is?
It's just 5.0.
Oh, is 5.0 the best you can possibly do?
Yeah.
Yeah.
Oh, okay. Then yeah, we should just set perf equal to score over 5, and then we'll have a 1-0 normalized metric.
Mm-hmm.
Yeah, it's basically full solved. So cool. All right. Boom.
There we go. It's doing it.
That's pretty decent. Heck of a lot better than I could fly a quadcopter. Nice. Solid. All right. If I suddenly disconnect, it's because I have some electricians messing with my power that I will have to go yell at. FYI. And I
Right.
will reconnect
Okay.
on my phone.
Sure.
People keep messing with my power and killing my runs. Drive me nuts.
Yeah.
Alright, so I wanted to check your compute. This is the target, right?
Yeah.
Let's just do just try something real quick.
All right. That seems.
Okay.
This is a position independent encoding, so the problem looks the same to it now, regardless of where the target is.
Yeah.
Okay, that's already training faster.
Yeah.
Sometimes the RL foo is quite simple.
Yeah.
Okay, that's pretty crazy.
If I couldn't do this type of stuff, people wouldn't stick around, right?
Yeah.
Mhm.
We were saying to some other people the other day, like back when we were using Gym and trying to train drone, we were operating our dorm room as like a data center, and like
Yeah.
all of our laptops were just running at full speed for multiple days, and now PufferLib can just do it in 5 minutes.
Yeah. Hey, that is the point.
Yeah.
I'm not spending the rest of my 20s here working out of a warehouse for in the middle of nowhere for no reason, right? Because we're building
Yeah,
some cool
true.
stuff. Alright, so that should be substantially easier here. Still's going to cap about the same because it's solved either way.
Mhm.
There you have it. Now let's see. What should we do? I don't know if this will mess it up, to be fair. But we will just fix this for you.
Thank you.
Probably doesn't mess anything up because probably what happens is you initialize them all the same, but then because the RNG is the RNG is in C is I believe it's process level. So even though you seed it, it's like as soon as it starts calling RNG functions from different ends on the same process, probably desyncs anyways.
Right.
But I mean, you can see here it's like that's 90% solved in less than 30 seconds.
Yeah.
Only 1.2 million steps per second. Let me check something. Oh. Just try spec let's just see if that does anything. No. This end should be faster than this, you know, a million steps a second is really any good. Here. Let's see if it still trains though. That's the question. There you go. 3 mil.
Well, okay.
That's like more
It's just-
respectable.
What did you just change? I like looked away for half a second.
It was 3 million steps per second. So it is. I set vector num-ems as 8, so you've got 8,000 total drones, or 8192 total drones. I bumped up the mini
Oh, yeah.
batch size a little bit,
Mm-hmm.
Okay.
and it
Nice.
looks like it still solves. So we just cut the training time down to 35 seconds total. Still solves.
Yep.
So we'll leave you these parameters in.
Nice.
Just so you can see. It does in fact work as I say.
Very nice.
35-second training to get a drone policy.
A pretty cool looking one as well, if I do say so myself.
Yeah, it's like very cool. Is there gravity?
Yep.
Yeah.
There is, right? Okay. Yeah, I was gonna say like it looks like pretty dang reasonable.
I mean, to do this in real life, you'd need a pretty nippy drone, but I imagine you can get one.
That's actually something we were considering looking at. Is like we could, if we were to do some hardware stuff, we could
Yeah.
make our own drones that would be
Mm-hmm.
ridiculously agile, just basically impossible to control for a human. And then we could RL
Yeah.
them, and we have superhuman drones, and then we're funded infinitely. Because that is that would be a easy 9-figure contract.
Wow.
Right. Okay.
I mean, think about it, right? Like it's like, hey, we have superhumanly agile drones that are autonomously controlled, right?
Yeah. Just don't forget us, okay?
Yeah. Oh, of course. Hey, I'm just thinking about like, hey, where do I get contracts? So I get you guys
Yeah,
involved because we're gonna need more people on this stuff. I don't want to be doing. This is actually the one thing I don't want to be doing is fiddling with the
Mhm.
damn fiddling with the math all day to like make sure it's to get it more and more realistic.
Yeah.
Because there might be, I'm sure that there's some additional forces or some additional phenomena that are not accounted for in this, right?
Yeah,
Yeah,
there's
no,
like
yeah.
gyroscopic effects and stuff that we didn't consider, and it wasn't too much more complicated to add it.
It's like 3 lines,
Yeah.
nothing.
Yeah. I think all like the planes and stuff, the physics for those is going to be more of a mess. But really, the that sim is more. It's not that one that I made. This like the large scale battle sim is more intended to show off like tactics more than anything. Which
Yeah.
the policy in there is just some default crap. Like it needs to be swept, and the obs suck. They literally can't even see each other in that, and they like already kind of work.
Mm-hmm.
Oh, look at that. That is solid. I almost don't want to like put a quadcopter model in because you're not going to be able to tell as easily. I
Yeah,
guess
we found the colors helped tell the orientation quite well.
I
Yeah.
guess you could paint like the top of it blue and the bottom of it red or something,
Yeah.
Yeah, that's a good idea.
and that would like kind of do it. But like you still don't get the full. Yeah, yours is like pretty nice. I think it would probably be good. What we would do is we should have it on a toggle. We should have it like actually be a quadcopter model, but then if you just press shift or whatever, press tab, then
Yeah.
it comes up. I do have a quadcopter model for you. So I don't think it probably is not just super trivial to add in. We'd have to maybe it is. I don't know, because you have to I don't know how you do the angle, because the way you guys have it now, it's just they're spheres. But I can show you the model that I have for this.
Mhm.
Yeah, sure.
Oh wait, did I? No, I didn't get a quadcopter model. It's like a different drone model. I forgot. So we would have to get one. Yeah,
Right,
yeah.
okay.
Because I went with I got the sci-fi looking model, but we could easily get one
All
of those.
right, okay.
Presumably there's loads on like the Unity asset store and
Yeah,
places.
yeah. There,
Yeah.
turbo squid everywhere. Nice. I mean, if you could do, I'm trying to think how hard a ring collision would. Because basically, if you just put rings, you're like almost to a racing end.
Yeah,
Yeah, that's
that
true.
would be cool.
Like the racing M's are just a bunch of rings. I think it's a little bit complicated because what you have to do is you have to generate like is it like a Bezier? You have to generate like some sort of like funky curve, right? That you use as
Yeah.
the track, and then you place some rings or like on that path.
Yeah, yeah.
Right. I've worked with Bezier curves before, so that shouldn't be too bad.
Mm-hmm.
Yeah, then this is perfect because like that's all the math that I do not want to have to do.
Okay.
It's perfect.
Great.
Yeah, because
Well,
like
we
I don't know if you've seen the
basically got-
autonomous drone, like this like superhuman drone racing RL. This stuff
Oh yeah, yeah.
a year
Yeah.
ago, right?
Did we read this paper?
I
can't remember.
think we did.
So like this stuff works, but like I bet we could do stuff like this so much better and so much more easily now with the speed, just pure
Yeah,
speed
yeah.
that we have. Like, you know that even like this thing, they probably did like some crazy sim in like Isaac or whatever that was super pain
Yeah.
to work with. Like, cause it eats Zurich. They do a whole bunch. Is this eats Zurich? H. I don't.
Is that? I think
I
it's
don't.
a Dutch university.
Okay, I'm not sure then. But like, you can just see like with built-in randomization, the level of simplicity and speed you'd be able to do this with now. And like, this is not even a complicated course. We could do way harder stuff than this.
Yeah.
These traces are pretty nice. I'll think about how to do those. I think we've done trails before. You just like render like some small shapes or whatever. You just like
Yeah.
have like a buffer and you just move the buffer over. It's like the last 10. Yeah, and then this is just like
This
right, this type of it looks way cooler
Super
with
cool.
the
Yeah.
I mean, that's literally just move the camera to first person perspective though.
Yeah.
Like you can see what I was talking about with the form factor though. Like look at the turn radius on these. Even these things, they have a huge turn radius.
Yeah, yeah.
So imagine if it were just like, super jagged. And they have human pilots, and then it's, they're it's all these kids, which is funny as well. It's like the same demographic is going to be, like the top at League of Legends or whatever will be top at drone racing.
Yeah.
It makes sense, right?
Yeah.
Yeah.
Looks fun.
Yeah. I'd be awful at that. We'll stick to the code. Okay, now for the fun part, let's get this onto the website for you.
Yeah.
How's
yeah.
that?
There we go.
All right, now the one thing is I don't think you did the C network stuff, right?
No.
All right, I'll show you how to do that real quick because it's cool. I made a thing to make it easy.
Cool. Will it be on like the live website today, or will it be when Puffer 3 releases?
When 3.0 releases.
Right. Okay.
Oh, and I'll have to get both of you. We'll add both of you to the contributors section of that right now as well, so that I don't forget to do it.
Okay.
Nice.
Cool.
What you do is you load in weights like this. Spencer, hey, yeah, I'm on with the drone guys in Discord now. Dude, they did awesome work on this. Like, we should actually chat about what we can do with industry stuff. Like, this is freaking cool.
Well, it's like 4 months now before we're back with uni work, so we're happy
Oh, yeah.
happy for whatever.
Let's get stuff
Like, we've got
fast
loads of time.
then. Let's get some stuff going fast. Let me just show you this real quick, Spencer. Like, look at this thing. Look at how cool the dynamics of this thing are. Like, that actually looks like how a drone would move. Unlike my sim, where I have like tons of agents and it looks cool, but the physics are jank as hell. And the code for it is super clean too. All right, so let me show you how this works. So what you do, puffer export, puffer drone. So all this does is this just takes the weights out of the PyTorch network in the order that they are listed, and then writes them to a binary file, just like NumPy saves them. And that format is literally just like, 4 bytes for first weight float, 4 bytes for second. That's all it is.
Mhm.
Okay. So what we do is we get this number, which is the total number of weights saved. We put this into here, and this will work for whatever n.
Yeah.
So now we need to know. Ooh, I didn't do continuous. Ah, shit! I didn't do continuous action sampling though.
Oh.
I'm gonna try to hack it, but yeah, I didn't do
Yeah,
continuous
yeah.
action sampling in this. So the thing that I wanted to show you though that's really cool, right? The thing I wanted to show you that's really cool is basically this thing. This is PufferNet. This is.
Mhm.
I don't know if I've mentioned this, but I might have.
Is this PyTorch in C?
Yes, this is PyTorch in pure C.
Yeah.
So we
Very
have
nice.
a 700 line file that has some common architectures, has comms, linear layers, LSTMs, exactly matching the way that it's written in PyTorch and tested.
Nice.
So what you can do is you can take your PyTorch weights, you can load them in, you do it in C, you compile the WebAssembly, and then for small networks, they just run in your browser.
Yeah, that's sick.
Very nice.
Which is like, if you tried to run stuff and compile for your browser before, it's a total nightmare. So this was the easy way of doing it. All right. Have to do. Yeah, this is slightly annoying. What I'll do is I'll just do like this. We'll custom it. It's not that bad. It's only this amount of code. Okay, so LSTM, the multi read. Now this should load this in. We need to know the ob size. It's 16, isn't it? 16, yes, 16.
I think so. Yeah.
So that's what it says. That and budget sizes. Budget sizes. Do not need to know. I suppose we do need to know that. Sizes. I believe that the way I should do this is I should do this as 4 and 1. This will trick it. This should be able to trick it into working, except have. Oh no, because it doesn't save log. Decoder log standard deviation. That is saved. Okay, so there is going to be one small modification. But aside from that, I really want to get this.
Yeah.
Reset actions. actions like this. So all we have to do is figure out the change that will be needed in order to make this viable.
Yep.
Is if I were to guess, I would think and then I just rewrite here net actor this. Yeah, I think it's going to be like this, and not logits. The end of actions I equals net, probably like actor output of I, if that's how I've done it. Yeah, output. So we'll see if this becomes total nightmare or not. I forgot about the continue thing. If not, we might just try to discretize because I think that'll train better anyways. So I should have
fair
a
enough.
continuous thing, but I don't want to keep you guys here forever if that doesn't work quickly.
Well, that's fine. We're unemployed and we've got exams.
Well, I'm also
Sorry.
hopefully you see some cool things because there are a bunch of things around with this as well.
Yeah.
I got a message back. There's a guy on X who like mentioned wanting to make a better one of these, like just like a pure C library.
Yeah.
There's a lot of weird crypto stuff these days, but it does have like some low level people who I could probably get to help.
Nice.
Pretty nice. Budget. This is. All right. Weights IDX less than thing. This is probably an architecture difference, unfortunately.
Right, okay.
Let me see. So this goes encode, encode, decode, decode value. Code, code, decode value. Oh, hang on. This is the same. So this should actually work. Decoder logged. So according to this, though, we are 4 weights off somehow. Maybe it didn't actually save. Oh, wait. Wait, 1 agent, 16 hidden size. Okay. Here I thought we were just gonna have nice, easy network. Oh, wait, you guys have a custom network, don't you? Is it just copy
Yeah.
pasted, or is it there be some difference?
I think so.
The only thing that might be different is the hidden layer size, but other than that, it'll
Oh,
be
what's your
exactly the
hidden
same.
layer size?
I can't remember. I think it was 128.
That's what ours is. I'm seeing it save and it looks fine. That's quite odd.
Would the LSTM you just added mess it up?
Yes, but the LSTM, I see it in, like, when I export the trained model, I see the LSTM here.
Right.
Good. Run. Alright, we have most powerful weapon. Is actually setting breakpoints in the freaking code. Okay, so this is the thing that kills it right here. I'm gonna retrain this just in case with our default policy.
Okay.
But we should do that anyways. Like, there's not much point to have and if that doesn't work, then we will discretize, and I will show you how to do that, so that at least there is something we can be shown here. Whatever we're gonna do, will we wait for it to train to take so long? Okay. C policy of Terra for you. Thank you very much. Yes, PR Terraform policy. Get that on the web today as well. I do have a 4 p.m. Yes, I've got a 4 p.m. So I got 45 minutes. I'm chatting with a robotics guy.
Nice.
Tell this one other guy who's bugging me. Better not screw. Hear the generator like making weird noises. They better not cut my power. He's so mad. 400 billion steps into an experiment as well.
Yeah.
That's 8,000 years worth of experience. Is crazy. Here's our drone. First of all, we'll check if the numbers match. The numbers do match, so Find integer overflow. Oh, you know why? Why? There we go. My bad. Now,
Nice.
it doesn't seem to do anything. So I believe it's... You output the mean. Do you just output the action mean directly?
I think for deterministic stuff, yeah.
Distribution's not normal. So this would just give you the normal sample.
Yeah.
I would think that that would work correctly, right? Because, like, if you just tell it, hey, you have a 4-way discrete output sampler, and actually, oh, hang on. Now that we fixed that error, I gotta shift the weights back, right? This
Oh
thing.
yeah.
Ah.
Oh yeah. Nice.
No.
Uh,
Uh-oh.
It's not exact, right? It's not exactly there. Maybe it's do we think it's relying on that sampling? It could be relying on the sampling. Because I didn't
Yeah,
do
that's very possible. That's very possible. Yeah, we'd find when you slow it right down, it can sometimes hover like that. Presumably
Okay.
because it tends to not get that close and not have already picked it up.
We will hack you a continuous sampler real quick. It's not that hard. Star. So we'll hack you a sampler, eh? Let drone follow the mouse. I don't know how to program the dynamics for that. That's actually kind of hard as well because it's 3D, even if you could.
Yeah.
Yeah.
Adrian submitted Tetris and Freeway yesterday, and the Tetris one looks in particular really good. I don't know if you've seen this. I was actually really surprised by how good this thing looks. Look at that.
Oh yeah.
That's
I
pretty
also
cool.
I had another researcher, a colleague of mine, literally the same day asked me like, "Hey, has anybody done like Tetris? I think it's a hard problem. You know, like I think maybe people have trained like it to clear 10 lines or whatever." And I basically said, "Yeah, it's stupid because it's the env is slow. I'm sure it'll work if the env weren't slow." Actually, wait, somebody's PR'd this. We can check. Lo and behold, no. The thing is, it's a hard problem if you're stuck with Atari training at 1,000 steps a second, but not like this.
Yeah.
Yeah. Yeah.
This looks sweet. That's better than I play.
It's far better than I play.
Yeah.
I don't think I have ever played.
You'll be able to play it here if you just hold shift. Like this is me playing technically, and I'm bad at my bad agent. You can take over. Okay. It's doing the shift thing, but it's refusing to listen to shift. Huh. Left shift? Iron. And then we have to do okay. So let's try to make sure that this is the same first, and then we'll add the standard deviation. And if this works and we decide that continuous actually does work and the other ends were just weird, then I will, later I'll make you guys just like a more proper module for this. We don't have to deal with this nonsense.
Cool.
Cool.
That's a pain, I know. Weights, data, yes. I know this was like one of the first things I did on Puffer because it let me run pure end to end on the web, and then that's kind of when I started committing to doing all this stuff in C.
Yeah.
Because it makes a big difference when you can actually just chuck your demos on the site. Project sizes. Okay, so this is the same as before where it can drift, but it can get stuck, I think.
hmm
Now we do your log standard deviation sampling. So what is it? Mean float std xf log standard deviation of I. Now what do we do? Rand n random normal. I forget we don't have nice things like rand n and c. Do I dare try to get one off of Grok? Alright. We'll see if I dare trust this thing. Computer blows up instantly.
Looks good.
If
Yep.
it gets stuck. That's actually kind of funny if this was the problem. Oh yeah. That's kind of funny that like it actually depends on the randomness.
Mm-hmm.
Yeah, we found that quite a lot with the old drone.
So I had to hack a couple things for you for this, but it does appear to work. So we can put this on the website just like that.
Nice.
Awesome.
Get rid of total steps. We also do need to get rid of these prints. All right, so now the magic here is literally just change this from fast to web,
Mm-hmm.
and then
Nice.
with my generator. See. This, copy all that stuff. We get a thumbnail. That.
Cool.
And then all I have to do is add you docs. All I have to do is add you a template. We put drone. Right, let's see.
Right at the top, surely.
Not too far from it. We'll do right after the really big sims.
Mm-hmm. Cool.
And yeah, how should I list both of you? Because I have to add you here and to the contributors page.
I guess
I'll go with full name, please, Sam Turner.
Yeah.
Sam, let me find. I just have Sam. How do I spell last name?
Turner. T for like Titan. Turner.
Oh, Sam Turner.
Yep. That's
Yeah.
the one.
And Finlay, Finlay, and then Sanders, Sanders. That's the one. Nice.
I need to figure out the rest of this thing. Perfect. 1080. So our preferred resolution. Fact works the best for everything. Okay, so two things we gotta do. One is check shows up immediately just on the website.
Nice.
It looks slower. Is
It
that?
does look slower, doesn't it? Can't possibly be from lag. See how you have it in C. Not window close. You have target FPS set to 60. I can't imagine that this would be low.
Is anything training at the minute, or?
Shouldn't be. You check the other M's. Oh.
Yeah.
All net. Oh, but the drone itself is there anything based on time?
I don't think so.
Not really, no.
Nothing based on frame. Because, like, look at this. This seems to be moving. Like, these stats seem to be updating at a reasonable rate.
Yeah.
Okay, that's a little interesting. So I do get
Could
some
it be
lag on
the-
this end, but I get lag on this end because I have 1,000 agents running.
Yeah.
Yeah.
Everything else
Could
should
it be
fine.
the network?
Could be, but your net
Maybe.
is pretty small.
Yeah, I guess.
I mean, this is the same network basically that I trained for you guys, but running 1,000 agents. So it's not lag. Yeah, there's something with mscripting, right? You know, it might be something with like these continuous ends, where like I think your browser kind of just decides to render stuff whenever. There might have to be some sort of interpolation.
Right.
I mean,
It's a bit of a bummer. It's slower on here.
Let me think how we can hack this. Native. All right, let me get you onto the site first, and then we'll check that out. Because you also get to go on this page. Go right here. I'll reverse it. I'll do it one order one way and the other if that's chill.
Yep, that's good.
Yeah, nice.
Awesome.
Rocket Lander was me attempting to hack on it, and then Morgenstein attempted to do stuff, and nobody finished it. Can you show drone.c again? Yeah, Adrian. It's just in a while window should close loop. Why is it a linear cont? Not linear because it has continuous action. So I had to hack them a continuous action space in C. Do you think this thing is slow? It shouldn't be, right? No, there's no way this is slow. Just a random.
Yeah, it doesn't look like it.
Definitely faster here. Much faster. Then easiest for this. Oh, easiest fix for this. Hang on. I just build it half a faster FPS? See if it like 120 didn't fix it for me. Did you try this? I've tried everything that you'll think of in the next few hours. Lovely.
Great.
It's weird because we have ends where it's not a problem.
Hmm.
The whole web ecosystem is kind of just broken. Web people don't actually know how to write code, turns out. I mean, you can just look at React and say, really, these people know how to write code? No, they don't. So 120 doesn't seem to fix it at all, right?
Yeah.
It's just frame rate capped, it looks like.
Yeah.
Banner.
Mhm.
Alright, so Band-Aid patch. For speed.
What are you looking for?
Actually, here, what we can do is... I know what we're gonna do to fix this. Tick. Pro.
Okay.
Assuming the rendering is slow, we'll just downsample the rendering to 30 while keeping the internals the same.
Mm-hmm.
Size issue? What do you mean a size issue? Okay, so that's super fast when I do it locally, but... I don't know
Yeah,
if
it
it
looks
actually is
exactly the same.
I don't know if it's actually reloaded it is the thing. We'd have to do
Ah.
something to test if it's actually been reloaded, right? Let's crank it like way the heck up.
Mm-hmm.
Like sometimes it just caches and it's good. And actually, hang on. Ah, see, that's what I was afraid of. Okay. Huh. So that is the ridiculous downsampled one.
Yeah.
Can't tell if it's any faster.
Yeah.
It does seem slower, right?
Yeah, definitely.
So I
Yeah.
know that you can get this type of stuff if you don't have put this in a while loop or whatever, you can screw it up. But the way it's supposed to work is that the only difference with web versus local is that your browser kind of just decides when it's going to give you compute time. I think that there should be anything super heavy though. This end like at all. I mean, there's definitely a performance factor gap between like web and normal, but like if I do, I should be able to do your end at like 600 FPS locally, no problem. See if this hits. Yeah, so this is fast drone.
Yeah.
This is like the
Very
type of
fast.
this is the type of drone that we would like to create. Right? This is the type of drone we would like to create. I mean, that's like, yeah. Oh, I wonder if it's this thing. Trying to fix this for you because it's like it's such a cool end.
Yeah, it'd be nice if it's full speed.
So
Yeah.
okay, another thing. Megs of data. Yeah, I'm trying to think what it would be that they have, right? Like, don't need this is window ready for sure. Dense all your code in for no reason. It's weird because I don't actually see this on my ends. Like, except for the ones where it's obviously gonna lag because the net is too slow. Do we think it's text?
It very well could be.
It could be that the M script and like the text is just different. You made some changes to Terraform C dynamics to not be so aggressive. No, I made changes to the controls in the .c so that it would not. I made changes to the controls and the way that actions are gotten from your presses, so it doesn't set you to like the max accel instantly. I should not have changed the C dynamics. No, it is not pushed. But it should not change your policy. Okay, so this is the normal speed, right?
Yep.
Of course, there's one memory, my fault. And still slow, isn't it?
Yeah.
Yeah.
It's like maddening. You have a sleep or something? You don't have like a sleep call anywhere.
No.
Gotta love M scripting. Let's see, Raylib M scripting. Then it renders slow. This is ridiculous. Raylib really good. M scripting bad. Raylib good. Actually, I think Raylib's the best piece of software I've ever worked with.
Mm-hmm.
Really good. Brave? Why would I do that? Gotta work on Chrome. I'm trying to think if there's any calls that I see in here that I don't use in my env. You don't have any trace logs here that like aren't on error paths, yeah?
I think so, yeah.
I don't think so.
They're just for errors from slower than Brave. Yeah, but it shouldn't matter. This thing should render 600 FPS if we want it to. Make. Okay, so the way you did it is technically fine. Because you make this is actually all redundant, funny enough. Literally just delete that. Provided you do this. We'll make it on the first reset. Okay. How do I make your thing fast? Trying to figure out here. I mean, the most likely thing I can think of, because like it still looked slow even when we did this like tick down sampling, right? Like even if I did this, like here, if
Yeah.
I do this locally, this should be zoom in, right?
Yeah.
That's like not even. Yeah, that should just be zooming. But then if I do this on web, if this is slow, what this implies is that the actual environment code itself is running too slowly to keep up, right? So look at this. The actual
Yeah.
environment code itself is running too slowly to keep up. So basically that means that something is compiling just garbage on web specifically for some dumb reason.
Right.
Awesome.
Which is, I know, really, really fun to figure out. Got one more idea and then I gotta figure out meeting.
Yeah.
IoT. It's kind of reaching a bit, but sometimes if it generated like a massive build or something like that. Yeah, no, it's the env dynamics themselves somehow are not being called frequently enough.
Right.
It's
Okay.
super weird. Like you see, and it's weird because like your env runs super fast.
Yeah.
There's like no mem allocation. But your own quaternion logic, which is fine. Not a single thing in here that should be weird. That's just rough. Like, it's implied that it is the step function.
Mm-hmm.
Could it be all the rundufs, the random floats? I don't see why it would be, but
What, like you think it doesn't handle inline keyword correctly or something?
I don't know.
We'll try it real quick. Here, this is what we'll do. Nest static line. Do anything. That's weird. I have been getting these WebGL errors lately. I wonder if there is some weird thing happening.
Yeah.
Just base PufferLib install though. That's super obnoxious. I mean, we can technically solve it just by jacking up the speed of this a little bit. Retrain with that. I will leave it to you to figure out how you'd like me to deal with this. The source thing, we'll figure it out eventually. It's just like I don't know what the heck is wrong with it.
Right.
Yeah, fair enough. I can have a look at it tomorrow at some point.
Yeah. I've kind of shown you the whole process. Why does this not? Why are we not? Did I do something dumb? Why /drone not work? What? How did I break your env? Eh. I'm confused. Come on, how did I do that?
Okay.
I didn't change anything, did I? What was the last thing I even did? Oh. I somehow undid this change.
Oh, okay.
Okay, we're good. So it still runs at least. Okay, let's get this onto get these fixes into this. So, because I added this env and I didn't commit it.
Nice.
Okay, so yeah, here it is on the site. Go to the home page. Listed here.
Awesome.
With all the contributors. It's quite a list at this point. And then we'll have this env will be here for now. We could figure out some fun ways to jazz this up. Maybe it's just the quadcopter or whatever.
Yeah.
And yeah, there will be much more drone stuff going forward. So I think we'll be. You guys are free to play around with multi-agent if you want. It really would not be hard at all to do. I mean, you could literally retrofit either the physics of your env into any of our EMs or our multi-agent into any of yours. So if you go find this HTML, it's in the puffer.ai repo under the dev branch. It's just Ocean HTML. So these docs are way better than what's on 2.0.
Okay.
And it has like
Definitely have a look at that.
it has this PufferLib style cheat sheet, and then it has examples. But then the main thing is it has this little guide on writing env, which you probably know most of. It's got these checks, but it takes you through basically the reference env, which is target. I built this thing as a commented example to make it really easy to build multi stuff. So this is like a trains in 30 seconds, simple as possible, multi-agent fun env.
Nice.
And like the dynamics of this, basically you add like 50 lines or maybe 100 lines max to this and you get this.
Great.
So yeah, take a look at that. Thanks guys. I will get to meeting. This is an awesome env and I look forward to doing more drone stuff with y'all.
Amazing.
Awesome.
Thank you so much, Joseph.
Bye.
Thank
See you in
you.
a bit.
Bye.
It was fun. All right. I am going to head out to meeting. I will be back afterwards, probably for. We'll see if I come back before dinner or after dinner. I might just take the time to like go figure out who I'm gonna hire for the Upwork thing before dinner, or I might just come back and hang out and record all the videos that I need to do. Thanks for tuning in. If you're interested in my work generally and you want to get involved, just like these folks have, Puffer.ai for all the things. Link to the Discord. You can start the GitHub to help us out. Really helps us out for free. And other than that, you can follow me on X or